Hello class 5. So here we meet again for another science class. You must have seen the first video where we have started the topic air. First part of the air we have already done. I hope all of you have gone through it and you have understood. Now what did we learn into that first video? What is air? We learned there. What is air? That it's a matter. Through some experiments also we did, and we proved that air has weight, air takes up space, and air exerts pressure. You did that experiment, glass and cardboard experiment, and you must have seen that air exerts pressure. So 3 characteristic features or 3 properties already we have done. Today we are going to do few more to learn about some more properties about air. Now the next one that we are going to do now is to see that air contains water. We say that air contains water. But then you can ask me, if air contains water, why is it that we are not getting wet? Why is it that we are dry? It's because the water which is present in air is not in the liquid form, but it's in the form of the water vapor. That's what we are going to prove. And for this, I've already set up the experiment of this. I had taken some ice cubes into this glass, and it's about 10 minutes before I kept the ice cubes into this glass, and I left it like this. Now you can see drops of water here outside. Little bit of vapor, tiny vapor is also formed here, and you can see little bit of water here. At the beginning there was no water in this plate. It was absolutely dry. Now from where these water drops or this water vapor is coming? There's no hole, the glass is intact, there's no hole on the wall, water can't come from inside. So from where this water has come? It's actually the water which is present in the atmosphere in form of the vapor. You know, when vapor condenses or the water vapor cools down, it changes into liquid state, the water. So what has happened here? Because of the ice, the surface of the glass has become very, very cold. It's absolutely cold. And when the vapor of the air touches this cold surface, cools down. So the water vapor, after touching this glass, because it's very cold, this glass surface, they condense, and when they condense, they change into the water vapor, water drops. So here this water actually, this is the water that's you can see here. It's actually from the air. The water vapor present in the air is formed here in form of the air after cooling down. So it can, by this experiment we prove that air contains water in form of water vapor. Already I've written it here, that air contains water vapor. That is one of the components of the air. We'll do later on, when we do the composition, we'll again come back to this point. This is one. Now next one experiment more we will do. That will also show you another property of air. I've taken one candle. I'm lighting this candle. And I'll fix it on this plate. Now, if I leave it like that, if I leave the candle like that, it remains like that. It continues to burn, no problem. It will burn, and it will burn till the last part of the wick, and then it will go off. But then what will happen if I cover this candle with a glass? I've got this glass here. I'll dry up this glass. Now this candle is burning. You can see nothing is happening, it's continuing to burn. But then I'm covering it with a glass. See, little bit, again little further, it's still burning, still burning. Now I completely cover it with this glass. What is the observation? What do we see? That the flame, it has extinguished. Why? If it was not covered, it was burning. It would have continued to burn, but as soon as I have covered it, it stops burning. It goes off, extinguished. What does it mean? Like you have seen, if any person's clothes catch fire, what do? They roll the person with a blanket, roll them down on the floor. They cover with the blanket and roll them down on the floor. Why? What is the reason? What is the part of the air here? It means air is helping the candle to burn. Air helps anything to burn. When I covered it with a glass, what did I do? I blocked the air. I cut off the air. I did not allow the air to come here. So naturally, in absence of air, what has happened? It got extinguished. So from here we get another property, that is air helps in burning. This one, we can show it with the diagram. This is the glass. This is the glass that I did the first experiment with you today, and I had put some ice cubes inside and I had kept it on a plate. Now after about 15 minutes, what did we see? Ice, it has melted here. We can see some of the water drops and little pool of water here on the plate. So this water outside proves that this is the water vapor from air which has changed into the water after condensation. Clear? And how do we show this experiment? A small diagram. Candle, you apply heat, you are giving heat, and it is burning. But in the second case, what has happened? What has happened here? This is burning and this has, what has happened? This is stopped, extinguished. Why? Because this is covered with the glass. So air has been cut off. Clear? Now we'll do one more experiment here, behavior of hot and cold air. That also is very interesting. It will take little time, but we'll do it. What is the behavior? When air becomes hot, how does it behave? And when air is cool, how does it behave? What we have done, I've taken a bottle. If you do this experiment at home, try to take a smaller one, smaller bottle, it will be faster. I managed to get only this bottle. And we have taken a balloon, nothing inside the balloon. Balloon is absolutely empty, nothing inside. Now stretch the balloon and fix it at the mouth of the bottle, just you can see as I have done it here. Now we have to heat the bottle for some time. Why? What is inside the bottle? Air. So if I'm heating the bottle, what will happen to that air? It will also become hot because we are heating the bottle. Obviously the air inside is becoming hot. Now how does it behave? Let's see. Now as it's being done, can you guess what could happen? When the air inside is becoming hot, how will they behave? You have seen in your washroom, that, I'll keep it here. Yeah, you have seen in your washroom, we have got ventilators on top, higher up on the walls. Have you noticed that? Windows are below, but the ventilators are on top. Even in the cinema hall, when you go to the cinema hall, you have seen big exhaust fan ventilators are there. So what happens? Why they are put up high on the walls? It's because when the air becomes hot, what happens? They expand, they rise. Hot particles, they always move upwards. So because they move upwards, that's why the ventilators are up there, because the hot air will go out and from the window the cold air will come in. So based on that theory, if we do this experiment, you can see little, do you see any change in the balloon? It will take little time, maybe 2 minutes more, for the air to become hot and move upwards. You can see it slightly, little more. Let's give 2 minutes more to it, and then. So, but by that time we can carry on with our theory part, that hot air, when it blows, when it moves, it always moves upwards, and cold air always moves downwards. And that scientific term we have got for that. You will learn that. We use the two terms. One is expand, the other one is contract. Hot air always expand. Expand means move upward, they spread. And cold air, they always come downwards. So that is the reason. This is through this simple experiment we can prove. See a little bit the balloon. Look at the balloon now. You can see the balloon. It's a little bit. You can see it. It's getting filled with the air. Can you see that? I can show it to you. I'm holding it. I can show it to you here. So this is a simple experiment. You can try it at home and do it and see it yourself. This will absolutely, it will get blown like this. So as we are doing it in the class, this much is enough for you. So hot air, what do we see? When the hot air moves upwards, the balloon becomes like this. And if you leave that bottle for some time, for half an hour to cool, again you will see the balloon will again come back to its normal position. So this is here, behavior hot and cold air. The two new words I'll just write, expand and contract, right? Hot air expand and cold air contracts. So this is the diagram you can draw. This is the normal condition. Is being heated, so balloon will expand. Okay, the balloon will expand, and when it cools down, this is the hot air moving upwards and cool air contracting, and balloon comes back to its original position. Okay, this much for you for this class.